I think many of you know that there actually have already been over 100 Stanford faculty who have faculty who have spoken in the series. And thanks to today's speaker and to the lineup of speakers for the rest of the year, I think it's clear that the series is going to continue to be a major platform for the sharing of pedagogical wisdom at Stanford. But audiences are a crucial part of this whole process. So thank you so much for being part of the audience and perhaps for your questions later. It's now my pleasure to introduce to you Professor Carol Boggs, Professor Teaching of Biology, being Director of the Program in Human Biology, although she's on leave this year, Stanford Friends University Professor in Undergraduate Education, in other words, one of the Bass Fellows, and I'll say a little bit more about that shortly. Carol received her Bachelor's of Arts degree with high honors and special honors in zoology in 1973 from the University of Texas at Austin. She completed a PhD, also in zoology, in the same university in 1979. It was in that year that she first came to Stanford and began her unconventional, richly biodiverse, if I can use that terminology in this way, and highly successful career path to her current position on Stanford. And since Carol is a specialist in man-made and in natural environmental changes over ecological and environmental time, I found myself thinking about her career in similar terms. Though a transplant to Stanford, she seemed uniquely suited to this environment. She has thrived here and contributed in noteworthy ways to both its ecological and its evolutionary success. She has been a research associate, a lecturer, a senior research scientist, director of the Center for Conservation Biology, and since 2006, both being director of the program in human biology and professor teaching in biology. Along the way, she has edited a book delightfully called Butterflies, Ecology and Evolution in Flight from the University of Chicago, and over 80 hardcore scholarly articles, in addition to many editorials, book reviews, and more popular pieces. The impact of her research has been recognized by, among others, by the American Academy American Association for the Advancement of Science and the California Academy of Sciences, both of which have elected her as a fellow. At the same time, she's taught and advised on campus with distinction, earning, as I had mentioned, one of the prestigious Bass Fellows slots, and in addition, the award for Outstanding Faculty Advisor in Human Biology. This past spring, she was honored with the university's Dinkelspiel Award for distinctive contributions to undergraduate education, which you may know only 2 of those are given to faculty each year. And it's a measure of her devotion to teaching that when I contacted her about speaking in this series, she accepted as soon as the invitation caught up with her on her travels, even though she's currently on sabbatical and leave. So in closing, Carol contributes to the ecology. I wanted to mention that she contributes to the ecology of the campus in another noteworthy way by creating an oasis of calm and thoughtfulness in what is often a highly frenetic place. She always seems wonderfully grounded, even if she does study the flighty butterflies. As a result, as I mentioned, she has added incalculably to the Stanford environment and will now talk to us about mentoring outside the classroom, true hands-on teaching. Carol.
Thanks so much, Michelle, for that incredibly flattering introduction. I hope I can live up to it, particularly the bit about calm here. But I think that's just a figment of appearances. So what I wanted to do today was to tell you a little bit about some of the things that I've been doing with undergraduates outside the classroom in terms of teaching approaches and mentoring approaches. And the slides are in part to have a lot of pretty pictures and in part to remind me what it was I was going to say. But I would love it if you guys have questions or if you have experiences of your own or anything like that, just interrupt and let's make it a dialogue if we possibly can. Again, some of the things I'm going to be talking about are somewhat specific initially to field or laboratory experiences, but I think there are things that can be translated into the academic year, and I'll talk about that at the very end. So, as I said, I decided to talk about mentoring outside the classroom, true hands-on teaching, in part because that's what I was doing when Michelle issued the invitation, and in part because that's an area that I've put a bit of thought into recently. So what I do in my research and in some of the mentoring with undergraduates is I take them with me every summer to Rocky Mountain Biological Lab, which is a field station in central Colorado. It's possibly the premier or one of the premier field stations, terrestrial field stations, in the world. We tend to put ourselves in the same class as Woods Hole for the marine end of the world. And there's an opportunity to take students, in part with VPUE funding, but sometimes elsewise, there to get their first research experiences and their first understanding of what it's like to really learn on their own, to really be a scientist. The area is, as I said, in central Colorado in the Rocky Mountains. It's at 9,600 feet. There are very steep cliffs that you could fall off of if you really wanted to, if you were testosterone poisoned, as some of our students are. But nonetheless, there's also facilities that can sometimes be rustic. We're talking outhouses. We're talking cabins with hot and cold running chipmunks sometimes. But nonetheless, it's a place that has a really good sense of community. There are people from lots of other universities there. There's a chance for people to really see how what they've been doing at Stanford fits in with things that are being done elsewhere and other students' progresses and things other students are experiencing in their classroom situations. So the first trick in this thing, when I'm thinking about who I'm going to take with me and how I'm going to structure this mentorship, is actually selecting the undergrad research assistants that go with me. And common sense, basic common sense, is at the absolute top of my priority list. There's a lot of students who hear Rocky Mountains and they think, okay, I'm going to go climb mountains. I'm going to go spend my time basically scaling that cliff, which actually if you stick a piton in it, it crumbles. Or have never even thought about the possibilities of being hit by lightning if they're out in the field on top of a plateau or something, carrying a butterfly net. So basic common sense is something you can't exactly say, do you have basic common sense? But you can judge from their responses more or less what kinds of things you're likely to be running into with problems if you ask them questions like, what are your experiences in the outdoors, etc. And then give them a postulated scenario and see whether they say, oh my God, lightning? I would be so out of there. Or rather like, lightning, okay, that's kind of interesting. Motivation is also important. Do they really want to be there, or is this something they're doing simply to fill time? And in a sense, I'm setting myself up for success by selecting students who are appropriately motivated. Attention to detail is something that's critical for the work we're going to be doing with regard to collecting data. But flexibility and group dynamics are also really important because the way I run the group depends a lot on the group dynamic being positive. It depends a lot on being able to foster good group dynamics. And so if it's down to 2 people and I know the rest of the group, I will go for the person who I think will fit in best in this kind of a scenario. And flexibility is really important to deal with both field work and hot and cold running chipmunks. So they have to be able to put up with that. Things that are not so important are previous coursework. It's something you might think I would be really concerned about, but I found that I can actually get them up to speed. I can actually fill in those gaps. So it's not such a particularly important thing that they have already taken biology, or that they're planning on being an Earth Systems major, or they're planning on being a Hum Bio major, or something like that. And I've had lots of students come with me and be very successful who are pre-med. They just want to get this experience for something that's a little bit broader. I've had one student who is now a grad student in philosophy at Princeton. So they're all over the place in that regard. So once we get there to Rocky Mountain Biological Lab for on-site preparation, I tell them, look, don't worry, just take all the right stuff with you. I give them a list, but don't worry about doing a lot of reading during finals week. We'll basically do some on-site preparation there. So I start off with a safety talk, what to do when it turns cloudy, how to ditch your butterfly net, when to run, what to watch out for in terms of bears, et cetera, et cetera, et cetera, and how not to fall off some of these cliffs. But once we get done with the safety talk, which I try my best to really scare them with, we end up having informal lab meetings, which are not necessarily on a regularly scheduled criteria, because we're in the field, we're flexible. So when it's rainy, we'll sit down inside. I'll have them read the background literature, but then it's up to them as a group to decide who's going to present what parts of it to the rest of the group. So this means there may be 10 papers from the primary literature. There may be 3 or 4 students. They split those papers up. They sometimes split the papers themselves up, and they will present it to the rest of the group as a summary, and end in particularly with questions that came out of it that they think are important as the next step for what one might investigate in the field. What are the unanswered things that might be of interest? I also have them read my grant proposal, which defines what it is we're doing. Go through that in gory detail, make sure they understand it, and at the same time, there also get them to critique the methods. Is this how they would do it? Sometimes they have a better idea. I think that's wonderful. Are there things that they think they might add to it as sub-projects that we could potentially do as a group? So this gets them in an interactive way, but also in dealing with the literature, in dealing with the background baseline knowledge, but it also starts to bond them as a group. It also starts to get them used to working with each other, used to interacting with each other, used to depending on each other's knowledge, used to the back and forth, which can be very, very helpful. And then we have running field discussions. We're out there walking around through the field. We'll bring in people from Rocky Mountain Biological Lab. That's Paul Ehrlich right there, out there with a student and me in the field at one point. And we'll have them just talk in the field about natural history, about previous studies, about their views of life, their views of how they got to where they are, their views of anything that comes to mind. Very, very, very open-ended, free-flowing, depending upon what the students themselves are actually interested in and responsive to that. Completely encourage questions. Even if I don't know the answer, they might point at some flower and say, "What's that?" And I'm like, "I don't know, the butterflies don't nectar on it." We'll have to look it up. But that's a good opportunity then to take them into the herbarium, show them how to use an herbarium, show them how to use the online resources to actually go and figure it out themselves, to get them started in that direction. And we also then connect back to the literature, connect back to the things they've been reading. So you guys remember, you know, you read about this. And so here's what it actually looks like in the field. And here's some things that go on from here. We also do some double checking of understanding. We're in a site where there's a lot of tourists coming through. Fortunately, we're not north of the I-70 corridor, so it's not Aspen, but we still have a fair number of tourists coming through. I don't know how many times I've been asked on a trail while carrying a butterfly net, how's the fishing? It's like, guys, if I get a fish in this, it's history. The net, that is, not the fish. So the other question is, you know, you'll have on a Rocky Mountain Biological Lab t-shirt or some other kind of a t-shirt, and you'll get asked all kinds of questions, ranging from what are you doing to I'm totally lost and this map claims that I'm supposed to be somewhere else and can you help me, etc. So we have them practice ahead of time their elevator speech. What are you going to say about what it is you're doing when you meet a tourist? If they can take that 15-page grant proposal that they've read and put it down to a 2-sentence response, they've got it. They understand it completely. If they can expand it to a 5-minute discussion, they really totally have it at that point. What do you do if you meet a donor? We entertain donors at RMBL all the time, including some Stanford donors who come out to visit and see what's going on at Stanford. This is one of Pete Bing's favorite places in the world. So they have a chance to interact as Stanford students with Pete because he's interested in seeing what Stanford students are doing out there. What do they say to him in terms of what it is they're doing? What do they say about how it fits into their Stanford education? What do they say in general to those kinds of questions? The tricky one is you meet a U.S. Forest Service employee. These guys know some biology. It's not necessarily true that these other guys, well, Pete knows a lot of biology, but it's not necessarily true that the tourist is going to know a lot of biology. What do you say to the U.S. Fish and Wildlife, to the U.S. Forest Service employee, particularly if you're in the wilderness area? What's the response? How do you tell them briefly what it is you're doing? So again, practicing these kinds of things. And it can end up being kind of funny. The local name for a tourist is a Turon, which is a cross between a tourist and a moron. So you sometimes have to be, you can get into a lot of jokes when you're talking about this, but you also have to watch out that you keep it respectful and that you keep things at the appropriate level in this case. So then what I do, once we're a bit into the season usually, although 2 summers ago we had a really late field season, so this happened at the very beginning. But once we're a bit into the season, so they know how to catch butterflies, they know how to process things, they've read the grant proposal, they can actually talk about what they're doing, etc. Then what I do is I try to set them up with a mini project, a mini independent project. And again, remember, these are students who, in general, have no research experience whatsoever coming in here. Sometimes they're freshmen, sometimes they're sophomores, but they've really never thought, even in the context often of labs, how to put together a research question, how to identify one, what to do with it, etc. So their mini independent project can be done as an individual, it can be done as a group, and some of that depends upon what different people are interested in. It depends upon the group dynamic, the personalities of the people involved. But what we'll do is we'll sit down and we'll say, okay, you guys have been making this list on the board here of all the questions that you've come up with in the course of the readings, and we've talked about things in the field. Here's some further background on some of the other systems that we've worked on in previous years, but not necessarily this year. What are you most interested in? Do you care about invasive species? Do you care about reintroductions of populations? Do you care about behavior? Do you care about what is it that turns you on? Give me some feedback in terms of what turns you on. So we'll do that. They'll come back with something. Sometimes they have a question or an idea that they really want to follow through on. Sometimes it's just, well, I kind of am interested in behavior. And I think it's kind of cool that there are these mites that feed on these eggs that we've been studying. And maybe there's something I could do there. Or sometimes there'll be some more distinct questions like, okay, so what's the impact of the butterfly that we're following on the plants that it feeds? That's something that's a more well-formulated question, something that's not just kind of vague, well, I'm kind of interested in that. But we'll do a bunch of give and take with me trying to get them to phrase the question, stimulating, asking questions, not kind of saying, well, here's a question, but drawing them out, taking them through the process of how you actually decide on a question. So we'll then take a look at that question and say, is this feasible? Do we have enough time left in the season to answer this question? And often that throws 9/10 of what they're thinking about out the door. Is it something that you can actually do with the equipment that we have available? Is it something that you can actually do in the amount of time that you have when you're not doing the RA work? Is it, those kinds of questions in terms of feasibility? Can we do it on land that is available to us to work on rather than on private land that's not available? Things like that. So we'll run through all of that. And then what we'll do is I'll say, okay, I want you guys to come back. You've now got your broad question. I want you to come back to me. Go away and think about it. But I want you to come back to me with a statement of your question with a question mark at the end of it, or a hypothesis that says, something that's formulated as a null hypothesis. And then I want you to derive a prediction, what you expect to happen either as an answer to that question or as an expected result that you would see from that, or prediction that follows from that hypothesis. So your hypothesis might be weather determines the amount of mortality of eggs of this particular species. So the question then would be, what's the relationship between X and Y? So it's a thing you're actually going to go out there and gather data about. So we'll go through that, we'll get the prediction down, we'll talk that through, make sure it's reasonable, and then I'll tell them to go away again and think overnight or over the next couple of days about the methods. They don't necessarily have to think about statistical analysis to start with, because none of them have ever taken a stats course. I can guarantee you that going in. But I want them to come back to me and say, okay, we would go out and we would measure the length of this. We would retrieve data from the station's weather data. We would go out and record every 5 days this parameter, etc. I want them to come back to me with a detailed methods situation. And I tell them, look, I have an idea for how to answer your question, but I'm not going to tell you what it is. I want you to come back and tell me, and then we'll talk through it. And after you've told me, I'll tell you my idea, and we can jointly figure out, if they're different, which one makes more sense. I'd say about half the time their ideas are better than mine, so that's pretty good. So it's actually pretty good. And then we'll walk through the statistical methods. I run a stats kind of a hands-on workshop that's very focused for what they need in this case. So the last thing then they do is they go out and they collect those data and bring them back in. We go through a guided data analysis, and then we start getting onto Google Docs, and the students write a draft. I have them start with the methods, and I have them start with the methods while they're still collecting the data, so that it's actually written down there no matter what happens. Then they start with the introduction. They need to have a context, and then they'll go through and do the rest of it. And we end up with something like this, which is currently sitting on Google Docs. The reason I'm first author rather than Libby is simply because what I'm doing in this case is adding in a whole nother year's worth of data that I have into the paper in the end. But this one should be submitted to Journal of Ecology sometime this year. And it's at the stage where it's waiting for me to make comments on their first draft in this case. So this is the goal. We don't always get to papers. Sometimes things completely fall apart. This summer we had one independent project that worked and another one that really didn't at all. But it gave us interesting pilot information. Okay, so I think there's a couple of keys to success. One is that the students have a lot of freedom to decide who does what within the group. So it's not like they've been assigned to you will do X, you will do Y. They have a lot of freedom to decide who's going to present what in the literature. They have a lot of freedom to decide what experimental project they're going to do completely. They have a lot of freedom to decide allocation of effort in terms of data collection, data analysis, data reduction, writing. There's nobody grading them in this case, so it's very much a unconstrained getting into it. And what happens is when I see that happening, other people are working, they feel like they have to work too. So it's a really self-generating, self-pushing forward kind of a scenario in this case. I also have them help each other on the project. So if two different people are doing different projects, they'll help each other with the data collection. And that switches off leadership roles. One person may be running one project, they're the leader on that project. Another person's running another project, they're the leader on that project. And they get to see what's going on, they get to get a broader experience in the field, but they're the leader on something. Taking it off here. We also end up with fun and bonding, and this is unfortunately a little bit too dark in this room. Picture on the, yeah, something behind it I think might be. Picture of our dry erase board last summer, partway through the summer. And what we were doing is we had an ice cream bet going. How many individuals of the population of Euphydrius gillettii were there that when we got done doing the data analysis? And so the numbers, Aimee is the 6-year-old offspring of my postdoc, but all the rest of us basically put up numbers for what we expected. And Amy came up with something in the end, but I don't remember what it was. And you know, whoever wins, free ice cream on me from the Gothic store. We also have lab signs, lab emblems, if you will, and then a whole bunch of other things that sort of keep track on there as well. But in this case, the person who won was Winston, who did 1,776. This is Winston with his ice cream. The following day, after we finished doing the data analysis, and I'd taken them through the data analysis, we had 1,800 individuals out there, so he was remarkably close in the data analysis. We also have non-ice cream bets. There was a semi-permanent snowfield up on the mountain. It was a really big drought this summer. The question was, is it going to melt before September 1 or not? It never has. So there was yes-no bets, which got recorded on Facebook, and followed by a photograph of the non-existent snow patch later on. Only glory was attached to winning that ice cream bet. There's also a lot of other things that happen outside of the research at the lab. We have lab parties. This is a semi-successful right side up, upside down pineapple cake. We have signs that are made often by the kids of people who are there for the lab door. There's mountain climbing. The 4th of July parade in Crested Butte is a little on the intense side. And then there's always the natural history things. I like this. The sharp-eyed research team from Stanford spotted a bear sitting in the middle of the Gothic Road. Sharp-eyed, middle of the Gothic Road. Right. So actually they nearly ran over the bear sitting in the middle of the Gothic Road. But in any event, so it's these kinds of things which also, outside of the work that we're doing together, help bond the people, help make it a good summer, a good experience for them. And they can also bring in other people from the lab in some of these experiences as well to foster a better sense of community. But I think that sense of community is also important. The other thing that I think is a key to success is that we engage actively in outreach. So it's not just those elevator speeches to tourists. The lab also has an environmental education program, and we every year participate in that, usually explaining butterflies to 5-year-olds or older, if I have my choice as to how old they're going to be, rather than 3- and 4-year-olds. So this is a student from last summer who is showing some kids who have been out there actually catching the butterflies, exactly what a butterfly is, how to tell how many legs it is, what the eyes do, sort of discussing the whole thing and bringing in a circular way, some of the stuff we're doing. They also participate in educational outreach for the local adults as well. So they're doing it at multiple levels. And I find the students are really enthused about this. They're really upset if this happens on a day when they're not in town for some reason or they can't participate. It's something they really, really look forward to. I think also giving them confidence with new experiences is really important, and it's also part of key to success. Encouraging them that you can do X, you can do Y, you can really do this. Showing them how it's done, working them through it. And it can be stuff ranging from science to something as simple as how to walk across a beaver dam. So Nora had never done that before. She was at one end saying, "You're kidding me. You want me to do what?" And I was like, "You're going to get from there to here. That's your only way unless you're going to swim." So basically we had a discussion about stay on the inside. It really will support you, etc. So we've got thumbs up here going all the way across. So, but that confidence, you know, like I said, extends into the academics, extends into other areas as well. The other thing that I've done is to use social media and blogs and Facebook to some extent. I started doing this using Facebook in part because I wanted to see my students' pictures. What I do at this point is early on in the year, I ask them if it's okay, if they're comfortable, if I friend them on Facebook, and explain that I want to see their pictures, I want to be able to share experiences and stuff like that, and they can always filter me out or unfriend me or whatever if they want later on, that's fine. I have yet to have anybody turn me down. They're usually excited that somebody's interested in seeing what it is they're doing and what it is they're up to. The students will also often have blogs that they run for their parents. So it's already something that's censored to some extent, but it usually is, you know, a description of, an amazing description, whether they realize it or not, of what I'm learning, how things are going, what it is I'm excited about. And they're a lot of fun to read, but it also gives me a lot of insight in terms of how things are going. Is somebody kind of wandering off into unhappiness in some way, or is there something major that they've put up there that's a misunderstanding about what we're doing, which I could then go in and correct, which I might not otherwise learn about, etc. But it's a way to basically learn from them, another way to get feedback from them and insights into understanding. Pinterest also works as well. It depends upon the student. I had one student this summer who just put pictures on Pinterest and she uses Facebook, but not all that much. So it's a way to build camaraderie, to build shared experiences, to build that sense of unity and of belonging, and we're in this together, we're all learning together in this case. It's also a place for good laughs. This is a redacted email that got sent 2 years ago and then got posted on Facebook. Basically, the outhouse latch had fallen down after she was in. Internet up until next summer is notoriously spotty at RMBL. So it's very good that both she had her cell phone with her and that there was good internet in that outhouse at that time. But you do get some, that's only one of the really funny things that sometimes get posted as well. So how to translate this into the academic year, into what one is doing if you're not as lucky as I am to be able to work out in the field during the summers in this case. One is that it's going to be less intense interactions, and one of the things that I often find when I come back to Stanford is the students' expectations who are continuing to work with me have been set a little bit high in terms of my availability for 24/7, since in the field we're really living together in this sense. So I have to kind of wean them back of, well, no, we can't actually meet on a weekend. Or, no, I can't come in this evening. But nonetheless, and as they start then picking up the rest of their obligations in the school year, that naturally happens. But again, it's less intense interactions. One can still, I think, build a certain amount of camaraderie, can still follow the same kinds of opportunities for leadership, opportunities for growth that one would have otherwise. You just have to put your expectations on a slower track, and you have to think about ways to keep the connections going without driving yourself nuts, without having such intense interactions with the students that it really saps all of your energy and all of your time. So you have to be very careful about setting boundaries, I think, in this way. But if you can set boundaries and make yourself available within those boundaries unconditionally, then I think that that works very, very well in this case. I also want to point out the role of grad students and postdocs. I've usually had recently either a grad student and or a postdoc with me out at the lab. And getting them involved in this whole process both gives them training as mentors and supervisors, which is critically important, but it also addresses something that as I get older relates to issues of generation gaps and sometimes of personality. I used to say I never wanted to have a student whose parents were younger than I was. I'm about to say I never want to have a student whose grandparents are younger than I am. But that does lead to a certain amount of differences in world outlook, differences in experience, etc. And it also, I think, even though we're trekking through the mud together, can sometimes make me feel, them have the perception that I'm a little more threatening or harder to approach or, you know, just sort of up there compared to a grad student or a postdoc in this case. So grad students and postdocs are more likely to go to some of the social events that they're attending, for example, than I am. I think the last time I went to a dorm party was when I was a grad student. So there's those kinds of different sorts of interactions that can happen. And I want to give you a student perspective on this. This is Lauren Panicio, who was a grad student, an undergrad working with me actually for 5 years. She showed up in my office hours as a freshman, insisting she absolutely would do anything in the world that I wanted her to do as long as she could work in my lab and work with me. She did a whole series of different sorts of research projects, including a really nice senior honors thesis, which is in the process of being published. Did a co-term and is now a grad student at the University of California at Berkeley. And she worked with me on a new student orientation presentation a couple of years ago. And the way I run those is I'll do some talk about how to get involved in research, and then I'll have the student who's coming with me give their perspective about how to get involved in research. And these next 4 slides are Lauren's. And the question was, whoops, how to find a professor, how to get involved in research. So this is me and Lauren at the edge of a cliff with a snowmass, Maroon Bells Wilderness area behind us. Her attitude is professors generally don't bite. Okay, this is a woman who had been working with me for 5 years. Still, I think, has more awe of me than I think is justified. But in any event, professors generally don't bite. You can find them in IntraSims. You can find them through office hours, which is how she showed up in my office. You can find them by emailing them. You can find them by going to lab meetings, etc. But which professor? So the question was how to stalk a professor. And again, this is useful because this is the student perspective, okay? How to stalk a professor. I love this spider here. Department website. Google Scholar. Not the way I would necessarily have thought of. It's something that students are really used to. Follow them around after class. Okay, that works. And then we've got grad students, the less intimidating option. So this is the grad student who she ended up being the closest to, who helped mentor some of the things. She did a research project with him. She and he still keep close track of each other. He's very lucky that's a Coke bottle rather than a beer in front of him in her pictures. And then the least intimidating option is other undergraduates. So I think this thing of generation gaps, of comfort levels, of hierarchy, no matter how much one might want to obliterate it, is really real. And I think the more you can introduce participation in the learning process from the undergrads, from the grad students, from the postdocs, the better it's going to work, because you'll have a lot higher comfort level. There'll always be somebody a student can go to and ask a question. There'll be a lot easier ways of learning in this case. I think that's Lauren right there, I'm not sure. But anyway, it's a trail, it's a path. And it's not always straightforward. It has its ups and downs, it has its curves. But generally it gets you where you're going, avoiding the pitfalls in between in the middle. And that's, in a sense, what I've been trying to do in this area. And I want to thank you guys for your attention, and a whole bunch of different groups of students over the years for helping me develop this in a much more thorough way. And what I'm hoping is that you guys have comments particularly on things you've done and things that also might help translate this more effectively into the academic year scenario. So I'll open the floor for questions since I've talked too much. Thoughts, comments? Yes?
Well, first I wanted to really congratulate you. I went to the undergraduate research symposium earlier this year, and one of your, who's only a freshman now, was presenting on butterflies. So it was just incredible. She wants to be in bio, which we talked about, geobiology program as well as human bio. Mm-hmm. The question, I guess the discussion I would like to have is, what sort of things that you've been doing out in the field would have a nice analog in an intro sem, trying to get the students to work with each other and learn from each other as well?
Yeah, well, I think the thing about presentations of literature would definitely work in an intro sim. I also think it's not out of the question if you have something that could involve a project. And it doesn't have to be a biology project in the field. It could be an engineering project. It could be a writing project in literature. It could be anything along those lines. If you have something that's complementary that you can work in, whether they actually carry it out or not, developing can also get them those critical thinking skills and the ability to really read through things and apply it in those senses. So I think, yeah, I think it'd be perfect for intro sims. Absolutely. And that freshman, by the way, she did have two collaborators who were both sophomores, but they were overseas right now. So, and that was the project this summer that worked. And once the overseas students come back in January, we're going to be working on a publication. Yes?
You mentioned that some of the students' projects work and end up into publications and some of them don't. How do you help the students who are working on the projects that don't work out keep their morale up and keep them motivated when they see their peers?
Usually the reason they don't work out is because we end up cramped for time in the field season. And what will happen is we'll still go through the data analysis, we'll still look at what they have, and then the question will be, okay, these are essentially preliminary data, they're exploratory data, they're starting to answer this question. Do you want to continue it next summer? Do you think this is a direction that's worth going in? What would you do differently? How would you redesign this? What do you think are the next steps? So even if it's not something they want to pursue, for example, is in more detail as a senior honors project or something like that, they've at least had the ability to say, this is where it should go, this is what the problem is, this is what I would change, this is how I would reset and start over if I were to do it again. Most of the time if they don't succeed, it's because we run out of time in the season. Sometimes it's because they don't have quite enough of a sample size to get a significant result, but that's usually fairly rare. It's usually an issue of time in the season in that case. And we can pretty much tell going in, I mean, I can give them a heads up as, okay, you're likely to run into time in the season problems, you're not necessarily likely to run into time in the season problems, but they, by the time they get there, they've got so much ownership of the project, they don't care. They just want to do it. Yeah.
Good. I just wanted a little side question was, do you have to send any of them home because of altitude?
I have never had to send anybody home because of altitude. That's one of the questions I ask is, have you spent time at high elevation, because we're at 9,600 feet, and do you have asthma problems? The lab also has a fairly extensive questionnaire that they have to fill out that asks those same questions over again. I came close to sending somebody home a couple of years ago for being an idiot. They turned out to fail the common sense criteria. Well, fortunately for her, she failed the common sense criteria about a week before she would have gone home anyway. So it wasn't worth booting her out, but it was, I don't want to repeat that again. But that's the closest I've ever come to having to send anybody home for any reason.
One of the things I was interested in, you said one of your criteria was flexibility, and that really resonates with when we talk to students about doing undergraduate research. When we ask them what the challenges are, a lot of the times it's recovering from failure or dealing with a lack of structure, or the transition from very structured academic environments with right answers to unstructured, open-ended, messy. And so I was just wondering if you had any thoughts about, even if you pick, you know, kids with higher sort of tolerance for flexibility, how do you help them develop that? And what, taking it back to Stanford, back to campus, are there ways you can think about trying to build those skills in normal classroom contexts?
Yeah. So one of the things that I do to try to develop it in the field is field research, particularly when you're dealing with butterflies that only fly in good weather. You've got to be flexible in your time schedule. So we'll work out a schedule for this is what we expect to do in the next 2 or 3 days. And I tell them, look, this is just going to completely vanish. We'll probably get through what we're going to do today and tomorrow, but beyond that, it may change. And so, and it may change for a variety of reasons, even non-weather conditions. So they get very used to moving schedules, very used to that kind of scenario. The living conditions themselves require flexibility in that regard. And also, as we're talking through the details of the research project, I ask a lot of what-if questions. What if that fails? What if this turns out that way? What are you going to do in response to this? So that both gets them thinking about how to troubleshoot, as well as used to the idea that there could be problems that happen along the way. So I think I wouldn't say that it's necessarily so important to give people the flexibility to be resilient in the face of challenges as it is important to give them troubleshooting skills. To give them the ability not to just panic and say, oh my God, this went bad sideways and oh eek, I'm totally frozen, but to then sit down and say, okay, here's exactly what happened. I can analyze where it went wrong, and what then would I do? What could I try to test where I think it went wrong? What could I do to change things to make it go right? But what can I do to test where it might have gone wrong is just as important. So it's those troubleshooting skills that I think are really critical. Question back here, and then Pat.
Hi, yes. I was just thinking about well, first of all, how this seems like such an incredible experience for a person to get in and really get a chance to absorb the material and learn things. But I was just wondering about when it comes to recruiting students, kind of what's your process about getting some people who probably really could, you know, benefit from just getting out there, but really just have no idea, have never considered, you know, this type of level of research? How do you build that interest up in students?
So there's a couple of things. One is, except for this year, I teach in the Hum Bio Corps in Fall Quarter. And so one of the examples that I use comes from my field research. And I talk about the fact that I take students with me to Colorado. And a little bit of a advertisement for students and say, look, anybody who's the least bit interested, come talk to me about this. I also find that students are really good at talking to each other. That has its pluses and its minuses, because then you get stuck in certain social circles within Stanford for a couple of years until you sort of break out of that, and then you get stuck in another social whirlpool, and et cetera. The other thing is that some of the people I've taken through the Hum Bio Research Experience Program or through the Biology Field Studies Program, those get advertised to those relevant students. I've also taken students through Earth Systems. Again, I lecture in Earth Systems 10, which is another way. I will always stick in an advertisement for I'm looking for students to do this, that, or the other in those. Occasionally, if I don't like the pool for some reason, or I don't think I have enough people who are really interested in working with me, as opposed to going to, you know, Peru to work with another grad student, I will sometimes send out a targeted email to different groups or ask other people to advertise as well. Yeah.
To answer this lady's question and put a plug in for our revamped undergraduate lab courses. We've actually launched them last year, and this year we actually even have a fall version of our winter course. But
this is biology.
Yeah, the guide is that it's a 10-week project where they're guided in some ways, but we really don't know the right answer. And they're like, we have 3 sections and 5 mutations being studied within those 10 sections. And we'll get the students together to compare their data. They're each doing it independently, but then they come together and they go, oh my God, why are we all over the map? And just start to talk about how you do research, how you design things, how you troubleshoot, what could go wrong. So we're hoping to build a stronger background in that sense for anyone who wants to then go out and do some projects.
Yeah, Michelle.
So, Carol, as you spoke, and also when Rob Dunbar spoke about the field experience in geology, I always think about the experience in a lot of the humanities and some of the social sciences. Anthro obviously has a big field component, but in history, for example, you might go to an archive somewhere else. But I was talking to a graduate student about this, and we were sort of comparing the possible dangers of doing geology in the field with the absence of danger in history archives. We concluded maybe the worst thing is you might choke on the dust.
Or get mugged on your way to the archive.
Yeah. And since there's some evidence that being in danger or in situations that require you to be very alert can actually make bonding more intense, I guess I just continue to wonder if there's some way that fields like history could have something a little more analogous to what you're able to give students when you take them out there. Because I feel when I listen to faculty who talk about their own and their students' experiences in the field, it has a little bit of that quality of soldiers who've been under fire together and will carry that for the rest of their lives. And I think in terms of building enthusiasm, building love of a subject, that's so powerful. And so I guess I'm just super envious and wondered if you have ever said to yourself, wow, if those historians would just do X.
Well, considering I started out thinking I might be an historian. No, the other thing that I would say in terms of people recognizing dangers, I have an absolute ban on iPods in the field, and the students don't always understand why until I point out the first pile of bear dung. And then usually it's like, oh, okay, I got it. But I think, yeah, I mean, there is a certain sense of we're in this together that comes from the excitement also of being in a new place. And exploring archives can be a little more solitary than something where there's 5 of you in the field chasing butterflies, even if you're on opposite sides of the site yelling at each other and then comparing notes. But I think that at the same time, what one could potentially do would be to think about how to use some of the social media to lend some visibility to what somebody is doing and what they're seeing and some interactions with other people, whether it's something along the lines of a blog or a Pinterest page or something like that, or whether it's that essentially documents. I mean, another one of my, for comparison, one of my grad students has got a blog that he's keeping, which is essentially an edited version of his lab notebook. Because he's got advisors who are working with him who are scattered across 3 buildings on campus. And it's a real pain for him to sort of go running around and get everybody up to date. So you just get this notice that says Rajiv has posted on his blog, and it's a summary of where he is at that point, and then everybody can comment back to him. And so I think one way to do something that would be parallel would be to make a blog that could be limited access or access by permission, where somebody's saying, hey, I just discovered X in the archives, I'm really super excited about it. And then have another group of people who are working on something maybe parallel or similar or slightly different come back and say, oh, wow, that's exciting. Have you thought about what this might mean? Or, hey, congratulations. Or, oh, bummer that that wasn't there. So you get that kind of social interaction, because I'm not so sure, I mean, it is the soldiers under fire, but it's also the social interaction, I think. And some students are much more tied into social interaction than others. I had people at both ends of the spectrum this summer. But for those that are, it can be a really helpful experience. But even for others, you know, it gives them feedback. It gives them the kind of instantaneous response that they're used to getting by now, the way technology is working. And there was an interesting article in, I think, the New York Times this morning on technology and its influence on learning as well. Over here somewhere?
Oh,
yeah. Yeah.
Well, just to speak to Michelle's question, just a couple of examples. One, I was going to share that Professor Berman teaches a sophomore college class on ghost stories, and they very deliberately use fear to engage literature. But also another example that I have from sophomore college is Professor Sagan, who does it has a field component. It's called Face of Battle. It's poli-sci class actually, but they go, say, to Little Bighorn and they walk the terrain of the battle. And in preparation, they have to, and this gets to something I think that you highlighted, where the students are making choices. So they adopt a persona of somebody who might have been in that field. And so just one example would be someone who was actually a pre-med student, but so the persona she adopted was being a doctor in this battle. And there is something about that choice making that you highlighted. And then the fact that they, in a sense, are sharing themselves in that process. And so it just also gets to that sense of where you not only have a technology that supports sharing, but that there's a sort of personal sharing or sense of personal investment.
Yes.
I was really struck by the way you developed the community of the students that you're working with. I wondered if you could talk a little bit about how you develop that for the graduate students and the postdocs, and what you look for when you select those people to come into your group.
So the postdocs, usually what I'm looking for is skills and ability to write and communicate and et cetera. So I'm not necessarily thinking, it does help if they have previous supervisory experience of some sort of undergrads, but usually that's not the top of my list. It's usually, do we get along? Do they have the skills that are needed for this? And usually I'm looking for something that's a narrow enough job description that there's only like about 5 people I'm really seriously considering. And again, the grad students, a lot of what I look for is different from what I'm looking for the undergrads. But I'm looking for people who have a solid background, know how to ask questions, have a good ability to look at things from both the 35,000-foot level and from the level of the understory under the trees. And also students who are good at communicating. As well. So those are often the primary things I'm looking for. Now those traits are the kinds of things that you also really need if you're going to be a good mentor. So it fits in together. Yeah, Robin?
Just also a comment on this idea of adrenaline outside the classroom. So in the field work, in order to get the data, we may find ourselves in a spot that makes us uncomfortable, or we've done something we didn't know we could physically do. So what's the beaver dam equivalent in history? And do we stop enough to say there are places where students, in the process of being a researcher in our field, where students and we go through uncomfortable spots, where we do something we didn't think we could do, where we feel exposed or in some way vulnerable. Mm-hmm. We probably do have those in all our fields. And when we think about opportunities to mentor outside the classroom, that's an opportunity to say, what is that in philosophy or history? Mm-hmm. And can I set it up so that a student can have this experience and have this success and make this stretch? Mm-hmm. I'm a geologist, so I share most of your, cliff stories. But those are real. And also realizing that students can be afraid, and when they're afraid, they're not learning.
Yeah.
And that also transcends disciplines. If I'm afraid of something that has to do with being successful in the archives, I'm not learning right. So.
Or you're not comfortable with the way you have to search because you're not really sure you understand it. Something like that. Yes.
So I'm missing the big picture. Where's the funding for this coming? I mean, you've got a research grant. Is there a line item that says mentor undergraduates? Or is it sort of folded in and expected?
No, the funding is coming from multiple places. One is it's coming from VPUE, a big chunk of it through the biofield studies and the HumBio research experience programs. So those are departmental programs. The stuff that happens at the lab during the year doesn't necessarily need that much funding. My grant does have money written into it for undergraduate research assistants. Yes.
Oh, okay. So I have a kind of a more strange question. It's really just trying to get your perspective as a faculty member. But as you mentioned, like, this experience is so intense, and it could otherwise become a draining thing to try to take on something of such a large scale throughout the school year. I'm just interested in knowing, though, if you have any kind of like examples or experiences of either yourself or maybe colleagues who are able to do maybe field trips or like just smaller type things that really at least whet people's appetite during the school year.
Absolutely, no question. And it's something that I would be often up for in this kind of thing. I mean, a conservation biology course, we've done field trips and things like that associated with it to show people what actually happens on the ground, get them a chance to talk to people who are practicing conservation biologists and et cetera. But a really good example of the kind of thing you're talking about, which unfortunately can't currently be done because Mexico is listed on the State Department warning list, is Rodolfo Dirzo's tropical biology course. So he took undergraduates to Mexico over spring break for 10 days. They did a really intense data collection exercise, both as a group and as individuals. And then he followed this up with a course in spring quarter where they learned how to analyze the data, how to put it all together. They ended up with a symposium. There's usually published papers of one sort or another that either come out of it or have their origins in it. And that both gives students a first taste of field biology in the tropics or subtropics, as well as other kinds of things. The Jasper Ridge Docent course is another really good example of something that's very immersive and has the coveted ability to be able to get onto Jasper Ridge without having to be guided at the end of it. So there's a really nice reward. So there's a variety of different things. I know the geology department does things extensively, etc. And I suspect that there's a lot of other departments elsewhere that do the same kinds of things.
And I'm afraid we'll have to make that the last question, but thank you so much.